If you have ever wanted to build an AI agent that actually thinks, not just responds, you will love this. In this video, I am kicking off a brand new series on LangGraph, an exciting open source framework that lets you build intelligent LLM agents using a graph based approach. So, quick introduction about myself. I am Ritesh, an AI engineer with 8 years of real world experience building scalable ML systems. And from past more than a year, I am using LangGraph to develop agentic applications. So, if you have worked with LangChain or are curious about next gen AI workflow, this is a series you should follow. And also, here is my LinkedIn ID. If you wish to follow you on this, you can do that. Before we deep dive into LangGraph, we should have a quick understanding of an agent. So, an agent, in simple terms, is like a smart assistant or helper that can observe, think, and act based on what it knows and what you ask it to do. Now, where does this LangGraph comes into the picture? We know LangGraph is used for making an agentic application, but what makes LangGraph so special is few of its capability. First and foremost, it's an open source framework. Second, unlike most framework that handle each interaction in isolation, LangGraph connects them like a flowchart, helping AI agents think, remember, and make smarter decisions with full context. So, if you are someone who is like an AI enthusiast or make some AI agentic application, I think LangGraph is something you should definitely learn. And also, this is one special capability of LangGraph that it's a low-level framework. That means you have the freedom to define, to kind of control the behavior of your agentic application, which is very important once you develop an application and once you productionize that application. So that's where the LangGraph really shines. Now, enough of talks, let's jump into the key components of LangGraph. Now, so there are 5 key components of LangGraph. Each are nodes, age, states, transition, events, and loop, and we will going to cover all of them one by one. So what is nodes? So think of node as a building blocks of your agent. Each node represent a specific action or a decision step. It's like you are defining a function in Python. It has some capabilities. Maybe it is used to call an database, or whether it's an it can be used to call a tool. So it's like a building block, and we create these nodes, and at the end we connect them. So think of nodes as a small Python function which is used for like it gives certain output. This is what the node is. Second is ages. So ages is something like it helps you to pass the information from one nodes to another. So if you see the diagram on the right hand side, so this is my start node which defines the starting point of my agentic application. Then we have something called as route question. So this is one of the node which I have created. So this will be my input point, and the input will going to pass through this edge, and it will going to reach to my second node, which is like the route question. And this line which you are seeing, dark line, it's nothing, it's called as age here. Third, which is state. So state is the most crucial part of a LangGraph, of an agentic application. So this is where we define all our variables, all our context which will be generated and which we want to store. You can consider state as like a brain of your AI application, of your agentic application. How we define state, how we define nodes, how we define ages, we will going to see it in few minutes in the demo session. But just think state as something like a brain of an agentic application. Now, there is something called as transition. So suppose right now I am in this node which is like the route question. Now from route question I need to go to like either my end node, or there is a different node which you are seeing which is like a generate node. So transition, it defines the rules for moving between these nodes. So this is what the transition is, because if you are making an agentic application, there are like different possibilities, there are different things your agent can do. So you need to specify certain rules before, what to say, before it goes to the next step. So this is what the transition is all about. And last is like the events and loop. So it's like a conditional flow. So this dotted line which you are seeing here, it's nothing but it's the conditional which I have defined internally in the agentic application. You will not going to see that condition. Once we go into the coding part, you will going to see that thing. So that's so the benefit of the loop is, suppose like once I reach to this node which is like my generate node, I wanted to call back my this node root function. So that's very much possible in LangGraph, whereas in many of the other frameworks such capability is not there. So this is also the positive of LangGraph. Now so this is the part of event and loop. Maybe once we have reached till one of this node and we want to add some human loop, like human what to say, like human in the loop. There is a concept called as human in the loop where we want some human feedback. So that's very much possible through this idea, event and loop. So these are the 5 key components of LangGraph. What are nodes? Just to reiterate myself, nodes are nothing. It's like a logical building blocks. It's like a Python function which is capable of doing something. Then we have edges where the connection or the information flows from one node to another. State is something like the brain of a agentic application. In transition, which defines the rule, and in loops, it's something like we kind of loop around, or it's like a conditional flow. Now, let's go to the demo part. So this is a quick Google Colab demo which I have created. So to make this demo work, I am using Google Gemini API key. So it's free of cost. So if you guys want to test it out, you can very well do that as well. So the way you can do it, just type Google Gemini API key. You will going to see this link. Just click on this link and then it will going to open. So here you need to click on that get a Gemini API key in the Google AI Studio. So this will open. Now below you are seeing, you can see like these are like this is the API key which I have created. So there is an option. So if you click on create API key, you will going to see kind of, so there are some projects which I've already created. So you can very well create any of the projects in Google Cloud and you can use the free API key for your development purpose, for the testing, for the learning purpose basically. So it's not a very difficult thing, but yeah, if you want me to make a video on how to set up this Google Gemini key, I can do that. But yeah, once we get this API key, what we can do, we can just go to the Google Colab, and these are the secrets. So here I have kind of saved my Gemini key, and here I have pasted my API key, and I will going to use that for my whole demo purpose. Now moving forward, so this is the LangGraph. This is the package which we need to install, and this LangChain Google GenAI is a package which we need to install, which kind of imports the Gemini keys with us. Now so these are the 2 lines which you might be familiar of. One is the chat prompt template which we will going to use from the LangChain uh, uh, package, and another is like the chat Google Gemini generative AI, which is like used for passing the API key and setting up our LLM model. So there is nothing what to say rocket science in this. This is quite easy. So these are like the standard step. I have loaded my Gemini API key into this variable, and I am kind of initiating my LLM instance. So here I have initialized my LLM. Now moving to next step. So this is something which I want to build. Now what's exactly is this? So I want to build a chatbot around a fitness application. So I want an application to answer questions related to the fitness, something related to the health and fitness basically. So just think of this possibility that right now I am making a very simple application, but the capabilities can very well be extended. So how I am making it? Let's go to the implementation step. Now this is the first key component that I have told you earlier, is like defining the state. So in this, what we are doing it, first thing, we are importing 3 methods, which is like the end, start, and the state graph method. And I'm importing that from langgraph.graph. And then from typing package, I am importing these modules which are like type, dict, list, and optional. So whenever we are defining a class of a state, so we need to pass this type dict, where we need to define like the what kind of string a particular variable will going to take. For example, for my agentic application, I need just three variables, which is like question, then we have classification, and then we have response. And in this question, the way it the string the type data type of the value for question should be string. The data type for classification I need to be dictionary, and for the response I need string, but it's kind of an optional. Now going to this, now this is an important step. So here what I am doing, here I am initializing the state graph with the defined state. So here I am defining the state, and in this point I am initializing the state graph, and state graph I am importing from this first line. Now once, so this is, so now you can, so this is something you can consider it to be, we have created a kind of a skeleton. Now in the skeleton we need to fit certain nodes as in certain capabilities we need to fit inside this workflow. Currently the workflow is blank here, it doesn't do anything. Okay, now going here, the first node that we have to create is called as the name of the node is root question, and I am and I have to import one like two extra methods, which is like JSON output parser and the string output parser from the LangChain core module. And the reason for this, I need this output is because I want my output to be in a JSON format. So that is the reason I have imported this method. Now just carefully see the structure of this function, like how I am defining the function and each and everything. So this is my node, and then here I am taking the state. What is state? State is nothing but the class which we have defined it. So we are importing this class, and there the second parameter, if you are saying, so this is a simple print statement. Now here I am importing, not importing, basically I am assigning the questions whatever the user is going to ask to my this question variable, and here I am creating a template. So basically the state which we have created, there we have defined three variables: question, classification, response. So my input point would be something like someone is asking a question, so that question will be assigned to this thing, this variable, and that value would be assigned to my this one. This is like in this template, that value will going to be fitted inside this question, this kind of the variable that I have, the placeholder that I have created. So this is a question template which I have created, and I am calling a chat prompt template from template, and I am passing this template here. Now then I am creating a kind of a chain where this is my question prompt, this is my LLM, I am calling the LLM, and the output I want into form of a JSON format. And here I am doing nothing. Here I am invoking the I am invoking this chain that I have created using question router dot invoke, and here I am passing the question. So if you see carefully what will happen, we will going to get an answer in the form of a JSON, and from JSON what I am doing, I am extracting the key, like which is my health key. So if you read about the prompt, the how I have defined, it's like you are an assistant which find whether the user query is related to health or not. If the query is related to the health, return yes, else return no. Give a binary choice yes or no based on the question. Return a JSON with a single key health. That's it. Now, and at the end what I am doing, whatever result which I am getting, I am assigning it to my classification variable, which is nothing but this is which I have defined in the state. So state of classification, I am assigning it to here, and at the end I am returning the state. So basically what is happening here, so in the state we had a question and we got the answer, and we are updating the state, and this state we will going to pass it to the next node, and this is how the information is going to flow. Now this is a structure of a node. This is simple. Now let's go to the next part, which is like decide next node. That means if you see this diagram, so from the root question we need to go in two directions. If the question is with respect to health and fitness, we should go till here, that is a generate node. If it's not, we will go to this end node. Now, how are we defining this action, specific action? So here what I'm doing, here is nothing. Again, we are taking the input as state, and here, and this is a return statement which I have written. So if the classification is yes, so here the answer that we would be getting is like give a binary choice, yes or no. So this is an expected output, which is like state.get classification.lower equals to yes. If it's yes, return true, else return false. So this is the simple behavior of my routing function, which you can see. Now, then comes the third node, which is like a generate node. And here it's again, this structure is very much similar to what we have created the first node. So here it's again, we are taking this as my parameter, state as a parameter. We already had the question into this variable, into question variable. So I am just extracting the questions from here. So this is the template which I am creating, answer the question in the quiz format, and I will going to pass the question. Again, I am taking help of chat prompt template from template, and I am passing this template, and I am using the string output parser because this time I want answer to be as a form of string, and then I am invoking my chain by passing the questions from here, and whatever response we are getting it, I am again storing to my third variable which we have defined here, okay. Now this is, I have stored the variable to my state, and I am returning the state again. So in this state, there are three components which I have added. One is for the question, another is for the classification, and another is for the answer. Now this can be very well extended to the n number of variables. Maybe you can create one variable for storing context. Maybe one variable you can create for storing some external result from outer source, from tools, something like that you can do. Now, so till this point, we have defined our nodes and our function, which is like the deciding function, classification function basically. Now, coming to the third step, which is like the graph setup function, like how we set up the graph. Till now, what we have done, we have created the nodes and we have defined the workflow. Like not completely workflow, but we have just initialized the workflow. Now we need to add these nodes into my workflow. This is what I will going to do right now. So what we do, we use add node method to add our nodes that we have created. So with this, we can create workflow.add node, and we are creating a route question, and then workflow.add node create a generate function. So these are my two nodes. That's what we are inserting here. Now just see this carefully. This function which we have created, which is like my classification function, this we are not keeping it as a node, because this is actually not a node, but rather it's a function which is used for determining where my LLM will go next, or whether in which path we will going to go. So this is what this function will going to be used. Now once we have added the nodes to the workflow, what we need to do, we need to add the age. Okay, so how are we defining the ages? So from start node, we need to go to the route question. So this is one age. Second age is like add conditional ages. So from the route question, I would be calling this function, which is like decide next node, and based on the response, which is like if it's true, then we will going to call this generate node, else we will going to call this end node. And there is one more age which we have to define. It's from the generate node to my end node, and at the end we need to do this workflow.compile, which will going to compile my whole workflow together. Whatever we have created, we can display this in the form of a graph. So from ipython.display package, there is two methods, which is like image and display, and you can use this piece of code to see how my agentic application is designed basically. So this is my start node, then we have the route question, then whether the question is related to health or not. If it's related to health and fitness, then it's written true, else written false. If it's true, it will go into this generate node, it will going to generate answer for me, and then it will going to end. So let's see how this works in the real time. So this is my question which I am passing in the form of dictionary, where question is explain about inflation. Now you very well know that this is not something related to health and fitness. So ideally it should go till route question and it should go till end. It should not trigger the generate function. So I am invoking app.invoke and I am passing this input. So app is nothing but this is the this is the after workflow.compile I have defined, I have assigned it to this app variable. And once I call this app.invoke, and if there is no response, then we print like no response generated, topic not related to the health and fitness. So let me trigger it. So we are saying here that no response generated, topic not related to the health and fitness. Suppose let us ask about explain about fat loss. Okay. I think this is related to the health and fitness, so we should get some good output. So we have got an answer that fat loss occurs when your body uses more energy than it consumes. This energy deficit forces your body to tap into stored fat and something. So this is working fine. Now just wait for a minute and think about the different possibilities that we have. Right now we have only created two nodes, that is route question, then we have the generate node for generating the answer. There might be some more nodes you can add which is doing some kind of research. There are some research paper which we can access. There are different tools out there. We can implement RAG in the in this workflow, in this agentic workflow. So the possibilities are endless. So the reason for showing me this demo was just to give you a small example how the LangGraph works, what are the key components, and how you can build the agentic application. Going forward, I will be focusing on making more complicated workflows, including including all the standard practices, all the techniques, all the advanced topics for creating. While creating an agentic application, I will trying to teach all of them to you. So this is my first video for the LangGraph series, and if you have like if you like the video and if you are watching till now, please do subscribe to the channel. It takes a lot of efforts to make such videos. It takes a lot of research, so that would be really helpful, and that would going to motivate me for making such videos a lot. So thanks a lot for your time.